rational expressions. Before we start multiplying and dividing rational expressions, we're going to do a little bit of review, and we're going to learn how to multiply and divide numbers, which is just regular fractions. We're going to do it without our calculators, okay? I mean, I know you can do it with your calculator, but we need to learn how to do it without our calculator so that we can then do these fractions, because these things don't work with calculators. Multiplying and dividing is easier than adding and subtracting, which is going to sound crazy because most people associate it the other way. The reason why it's easier than adding and subtracting is when you multiply fractions together, you don't need a common denominator, you don't need to do anything. All you do is you know that the multiplication goes with the numerators and it goes with the denominators. So it becomes 12 times 5 divided by 10 times 4. It gets that easy. So multiplying, you just go straight across the top, straight across the bottom, and it becomes 60 over 40. And obviously you can simplify that, right? Like both those numbers can be divided by 20, so it becomes 3 over 2. But the big thing you need to know is that multiplying is easy. Straight across the top, straight across the bottom. Division is a little bit trickier. So division doesn't go straight across the top, straight across the bottom. Instead, we try to change a division question into a multiplication question. And if you were with me last year in Math 20, you probably remember my saying of kiss and flip. So what you do is when you have a fraction divided by a fraction, we try to turn this into a multiplication. When you turn it into a multiplication, that's the kiss in the kiss and flip. Because when you do X and O's, the X's means kiss, the O's mean hug. So that's why we call it a kiss. You change the middle thing to a kiss, and then you flip this fraction, the one to the right. So your new question is now negative 3 over 5 times 20 over 3. It's called a kiss and flip. You turn a division question into a multiplication question. If you change it into a multiplication question, now it's easy again. Right? Straight across the top, straight across the bottom. So that's why we do the kiss and flip, to make it into something that's easy for us. Negative 3 times 20 give me negative 60 on the bottom at 50. Again, you could simplify that, it equals negative 4, but all we're really trying to remember is how do we multiply and divide fractions. That's how we do it. Last one. Give it a shot on your own. So it's a fraction divided by a fraction. I want you to see if you can do it. Use our little trick to make it happen. Try not to use your calculator unless you're just figuring out multiplication. So the first thing I did was I kissed and flipped it, right? I changed that division symbol into a multiplication symbol. I flipped the fraction to the right. So the one that you were dividing by, that's the one that flips. The first one stays the same. It's funny because kiss and flip is something I learned in grade 6 and I still use it like today for rational expressions. And it is a negative, it's just the negative is with the 8. So I just took the negative with the 8. So negative 1 times 24 was negative 24. 6 times negative 8 is negative 48. The negatives cancel each other out and become 1 over 2. So a negative divided by negative, the negatives cancel out. That's why it became positive 1. Alright, so that's what we're going to be doing today. We're going to multiply and divide rational expressions. Before we do that, you're going to notice when you get your unit assignment or when you're working in your practice booklet, or as we do our notes, that the very first thing you always do with every rational expression is you state your NPVs, your non-permissible values, okay? So that's what we learned yesterday as well. Anybody remember what a non-permissible value is? Yes, sir.
Well, I know what it is, but like for this specific question, don't we do the NPVs for the division?
Yeah.
It's the x minus 4 and the x plus 3.
Yeah, this one's going to be a little different than we've done before. But we're not quite there yet. I just want to remind everyone what an NPV is, so everyone's on the same track again. Something that makes you divide by 0, right? So if we were looking at this question yesterday, we would have said that the NPVs were x cannot equal 8 because 8 would have made this fraction divided by 0. And we also just said that x cannot equal -3. Negative 3 would have made that fraction divided by 0. Now what Sierra is saying is there's an extra thing here. So what I like to do is I say for every division symbol, there's a new area to check. We knew to check this first area because of this first division symbol. We need to check this second area below because of this division symbol. But now there's a third division symbol. It's right here. And that division symbol means you have to check this area to see what would make that thing equal 0. Here's my reasoning why. If this thing up here, this numerator, was equal to 0, 0 divided by anything is 0. And then you would have a fraction divided by 0. So that's why you have to check that third spot. So my NPVs for this question would be x cannot equal 8, -3, the first we did, and then +4, because of our new area that we have to check. Every division symbol makes you check a new area for non-permissible values. All right, we're going to simplify some things. So we're going to do 2 together, you're going to do 2 on your own. You'll see across the top, I've written something important. It's the steps to doing every question. Factor first, state your NPVs, and then start simplifying. So you don't do any simplifying until you've factored and then done your NPVs. So for this first question, my first step is factoring. I can't factor. So I'm done my first step. My second step is state your NPVs. I check my division areas. Nothing's making this first fraction 0. I check my second one and I say C cannot equal 0. If C was equal to 0, 2 times 0 would have been 0. 5 times D divided by 0 would have been not allowed.
So you put, write it like that, this can equal 0, or can you put NPVs?
Yeah, so this is how you'll typically see it. And this is called a restriction. But if they said, what are the NPVs, then you would say NPVs equal 0, x equals 0. Okay, so first thing, factor, did it. Second thing, NPVs, did it. Third thing, now you can simplify. So if we're going to multiply 2 fractions together, we just multiply straight across the top. So this is c squared times 5d. And you multiply straight across the bottom, which is 10 times 2c. So it just combines right into 1. If you multiply the top together, you get 5c squared d. Nothing can go together in that top one, so I just write it in alphabetical order. Below that, I have 10 times 2c, so the numbers can multiply together, so I have 20c. Okay, coefficients can multiply with coefficients. So this 10 can multiply with this 2 to become 20. All right, I combined my fractions together. That's perfect. I've done that completely right. And now we do what we did yesterday. We simplify it. We have to write this thing in simplest form. So you need to check your tops and your bottoms and see if there's anything that can cancel out. My 20 and my 5, they can both be divided by 5. So divide both of them by 5, and I'm going to have 1 over 4. I look at my c's. I have 2 c's on the top, so c squared, and 1 c on the bottom. So that means I'm left with 1 on the top. And I check my d's, and there's no d on the bottom, so just a 1 on the top, so it's still on the top. So your answer would be c times d divided by 4. Example 2. I'm going to follow my steps. First step is factor. Well, it's nice that they've already factored it for us. If we look at that thing, it's already been factored. Second step is state any NPVs that you have. NPVs are when you divide by 0. So I would say x cannot equal positive 1 or 0. If it was positive 1, the first fraction would be divided by 0. If it was 0, the second fraction would be divided by 0. Third step is now multiply things together across the top and across the bottom. Across the top, what I don't want you to do is mash all those like binomials and stuff together. It's going to create a massive trinomial. Instead, what I want you to do is just leave it in factored form the way it is. So when I write this thing out, the only thing I'm multiplying together is the two coefficients to become 20. And then I'm going to leave everything else alone. So x plus 3, x minus 1. The reason I'm doing that is I know after I multiply, I'm going to check to see if I can cancel things out. To be able to cancel things out, I have to be in factored form. Okay, so I have to do it that way. Divide by, and across the bottom, I'm going to do the same thing. I'm only going to multiply coefficients together. So the 2 and the 3 will go together to become 6. And then x minus 1. The order doesn't matter. So if you put 6 x minus 1 times x, it's the same thing. Alright, my final step is to check to see if anything can cancel out. Always check your coefficients first. My 20 and my 6. What can they both be divided by? 3. Nope, 2. They can both be divided by 2. So it becomes 10 divided by 3. The next thing I check is my single x. My single x on the top has a single x on the bottom. That means those things can cancel out. So you get rid of them. Then I check my x plus 3. Does it have any x plus 3 on the bottom it can cancel with? No, and remember when it's in brackets, that's like an entire package, right? Packages can only cancel with other packages. My next package I have is x minus 1. Is there an x minus 1 on the bottom I can cancel with? In this case, there is. So the only thing left is the x plus 3 on the top. So I have 10 times x plus 3, all divided by 3. Common mistake that people do here is they would try to cancel those 3's out. Remember, the 3 is in the brackets, it's part of the package. So you can't cancel it out with the 3 on the bottom. Alright, the next two are for you to try. I'll write the answer on the board. Don't forget to state your NPVs. Okay, so you have to state those somewhere. The second one is a little bit harder. The first thing you do is factor. It's already factored for you. The second thing is NPVs. I just want to point something out. If I did my NPVs right now at the answer stage, what would my NPV be? There wouldn't be an NPV on this question. That's why it's important you do your NPVs before you start messing around. So you factor it, then you do your NPVs, and then you start simplifying. Across the top, your coefficients created at 10, the x squared is still there, the x plus 2, x minus 4, they're all still separated out. On the bottom, the 3 and the 8 become 24, the x become the x squared, and the x plus 2 is still there.
On a quiz, I forget if it does this, but is it always going to ask the statement NPVs?
Yeah, so on a quiz, or even on a diploma or a multiple choice test, the NPVs will always be part of the answer. So for instance, if it was like, the answer is 5x minus 4 divided by 12. That might be option A. And option B might be the exact same thing, but with the NPVs put in. Option C might be the exact same thing, but with the NPVs, again, it's something different. Right? So they will have the NPVs for most of your answers as part of what you need to know. On this one, lots of things cancel out, so the x's completely wipe out, and the x plus 2 completely wipes out. Alright, multiplying is the easier one. Dividing is a little bit trickier, but we make it easier by changing it into a multiplication question. Before you kiss and flip, you have to list your NPVs. Right? That's always the same 3 steps. Factor, NPV, simplify. Always in that order. First step, factor to count. Second step is NPV. This thing looks like there's no NPVs because you look across the bottom and it looks good. But remember that new division symbol in the middle means you need to check up here to see what could equal 0. So we need to say n cannot equal 0 because of the numerator on the second fraction. It would be, everything you guys do multiple choice or anything, right? So you're good. But if it was like something that was written for me, like a unit set or something, I'm fine. Once I've stated my NPVs, now I simplify. I don't know how to divide two fractions. So I have to change it into a multiplication question. So I have to make it multiplication instead of division. And when I do that, the first fraction stays the same. The second fraction flips. So I kissed it, meaning changed it to a multiplication, and then I flipped the second fraction. There's something else here when we go to simplify that we need to do, and we have brackets and then a square. When the brackets have a monomial on the inside, all that means is the square goes to both names. So this question is going to become 5n to the 4 divided by -2 times 6 divided by 25. Right, so the square came into both names. Again, we multiply the top with the bottom, so this becomes 30n to the power of 4 divided by -50n squared. Your final answer is to combine anything you can. So on the top, I have 30, on the bottom I have -50. So in my calculator, I go 30 divided by -50, math frac, and you're going to get -3/5. If you thought to yourself, like, hey, they can both be divided by 10, that's good, but I would also float that negative to the top, and I don't leave negatives on the bottom. So it'd be -3/5 instead of 3 over -5. My n to the power of 4 divided by my n squared, we go to war, the n squared to the left wing on top. That would be my final answer. All right, last one. First step, factoring. Already factored. Second step, NPVs. I check 3 areas. I get x cannot equal 0, x cannot equal 2, and x cannot equal -1. The order that you write them does not matter. What matters is you know there's 3 of them. Then we simplify. When we simplify, we kiss and flip, so we change that middle thing to a multiplication. The one on the left stays the same. And we flip this in. We multiply across the top, multiply across the bottom. We're now going to have 2x, x plus 1, x minus 2, divided by 8x, x plus 1. Then we cancel out anything that we can. Right? The coefficients, the 2 divided by 8 is going to change to be 1/4. The x's are going to completely cancel out. The x plus 1s are going to completely cancel out. And you're left with x minus 2 divided by 4. That's what your final answer would look like most likely out of text. Notice that there's no brackets around the x minus 2 because there's no other things on the top. If you put brackets, that's okay. So if you had brackets around that x minus 2, that's fine. If you had a 1 in front of the brackets, that's also okay. But you don't need to write 1 times something because it doesn't change it. I screwed up somewhere. What did I screw up?
3 times 4, 8x.
Yeah, it should be 12. Yeah, I was like, I screwed up with something because I got a lot of like, what? On the plus side, still simplifies very nicely. So that should be 12, and then 6. For the same thing, you don't need to write the 1 on the top. When you had your 2 divided by 12 changed into 1 over 6, you don't need to write that 1 up top. You also don't have to have brackets around x minus 2. I always put brackets to remind myself they're a package. Okay, but in a final answer, if they took the brackets off, that's fine because brackets mean multiply, and it's not multiplying by anything. So they can go away. Okay, I'm going to write the answers to the next 2 while you practice them on your own and then see if you have the right answer. Been 0 in the first question, and then -5, 0, and 3 on the second question. Make sure, look at your NPVs right now, see if you actually wrote them out. So you'll be surprised how many times people don't write them out because they just forget. On your unit assignment, every question is going to get 1 mark for just doing your NPVs properly. So if you forget to do your NPVs, you'll get 50% knocked off your test. Right, like that quick. So state your NPVs, okay? Next thing I do is I kiss and flip both those things and then start canceling out. And you should have been left with 3x plus 5 divided by 4 for the right one, and then just 3n divided by 7 for the first one. Yeah.
Okay, so how do we figure out the NPV?
The NPVs are places that cause you to divide by 0. So every time I have a division symbol, like this division symbol from the fraction tells me I need to look right there to see what could make that thing 0. So I say, well, if x equals 0, that thing would be 0. So that means x cannot equal 0. Then I check another division symbol. This division symbol is this one right here. So that means x cannot equal 0 again, but x also can't equal -5. Because if you had -5, that thing would be 0. 0 times whatever that is would also be 0. Then you're dividing by 0. The third one comes from this division symbol right here, which is the one that people usually forget to check. If that thing's 0, then you're dividing by 0, and that's not good, so that means you can't have a 3 there.
You always start at the bottom line.
Order doesn't matter. You could go like green, red, blue if you wanted. I just always like go left and right. Okay, this is more a style question that you're going to end up getting. So the ones previous to this, you had already a factored equation. This one is not factored. So your first step comes back into play, and your first step so is factor. Factor everything you possibly can. So you're going to look at the top, the bottom, both fractions, and you're going to start factoring like a mad person. When you factor, that's why it's a good idea to have a scrap piece of paper. Because you're factoring 4 things. It's a lot of factoring. So on the top one, I would get a diamond, and it would be things that multiply to be 4 and add to be 5, and you get x plus 4 and x plus 1. And I'm not going to spend a lot of time factoring in front of you, because we don't have time and I don't have space on the board. On the bottom, you could diamond method that thing, but it's the first type of factor you always have to do. You have to take a GCF of a 2 out, and that's going to change all those values. Become 1, 4. So when you factor it, you end up with 2 things that multiply to be positive 4 and add to be negative 4 is x minus 2 and x minus 2. The second fraction. So I'm multiplied by. I look at the top. What's the first type of factoring I always try to do? Yeah.
Wait, how did you get the 2 on the bottom?
The 2, or the x minus 2, x minus 2. When I had my quadratic of x squared minus 4x plus 4, I diamond methoded it. I'm just doing it fast, like that. Like you're going to have to, that's why I give you so much practicing factoring, because you're going to need to practice it. This guy, all you're doing is taking 4 out, so then you're left with x minus 2. This guy on the bottom, you can't take a GCF out, but it's a binomial, and it's a binomial where everything's a perfect number, and it's subtraction. So that's called a difference of squares. So the factors to be x minus 1, x plus 1. First step was factor. And you probably see now why I kept saying factoring is so important. That's all three different types of factoring mashed into one question. And you got to know them all to be able to get this question right. So, practice your factoring. At this stage, what do I do after I factor? State your NPVs. Yeah, you've got to state all your NPVs before you start canceling things out. So my NPVs come from anything that divides by 0. I'm going to say x cannot equal positive 2. That make either of those first ones. And I'm going to say can equal positive or negative 1. Because that would make either of those bottom ones turn into 0. If you didn't factor and you looked at that question like the NPVs are and you started writing them out, a lot of people would get positive 1 and a lot of people wouldn't get negative 1. That's why the factoring is so important. Now, you need to multiply the tops, multiply the bottoms. If you're getting good at this stuff, you're going to notice that nothing along the top multiplies together. Right? The 4 is just going to move to the front of everything, and everything else stays the same. On the bottom, nothing can multiply together again. Right? You have all these different binomials. So, to write that out quickly, you're just going to go 4, x plus 4, x plus 1, x minus 2. Along the bottom, 2, x minus 2, x minus 2, x minus 1, x plus 1. And now you start partnering things up to simplify. The plus 1s can cancel out. The minus 2 can cancel out. The 4 and the 2 coefficients can cancel out from 2 and 1. So you've seen I've canceled out all the pairs I possibly can. And you'll notice I'm canceling out entire pairs, right? Group packages. So that x plus 1 is a grouped package. I can only cancel out with another x plus 1. Once I've done that, all I have left on the top is a 2 and an x plus 4. On the bottom, all I'm left with is x minus 2, x minus 1. Like that. So, factoring. Pretty important. I suggest you always bring a scrap piece of paper or a notebook to do your factoring in, or start writing real small and real organized. One or the other. Okay, the second one we're going to do together. The first step to all these questions is always the same. Factor them. So, factor that equation. I'm going to factor the top. I'm going to get a 2 on the outside. That leaves me with x minus 5. On the bottom, I can't factor it, but what I am going to do is I'm going to put brackets around it, because I'm going to remind myself that x plus 3 came together. It's a package, right? So put brackets around it. Just remind yourself, oh yeah, that's a package. Divide by. Across the top, you can take a GCF out of that thing. When you take a GCF out of it, you can take a 3, I think, out of all of them. Is that fair? Has anybody done it? So when you take a 3 out, you're going to be left with 4x squared minus 20x plus 20. So that's what happens after I take a 3 out. Yep.
Why is it? Wouldn't there be 2x minus 5 as well?
I took a 2 out of both things, so it'd be definitely a 2. That's beautiful. Like you never even make a mistake. Good catch.
Alright,
that's good. Well, someone's got to be that guy, or else I'm going to script the whole question. Over here, now you can factor that thing. Like that's one that's definitely going to require you to do your little diamond and figure things out. I will do it on the sideboard over here. So my diamond is going to be 4 times 25, or 100 on the top. The bottom is going to be negative 20 on the bottom. I'm looking for things that multiply to be 100 and add to be negative 20. So it means negative 10 and negative 10. So when you go to factor that thing, you're going to end up with 4x minus 10 and 4x minus 10. And you have to divide one of these by 4. Neither one can divide by 4. So you have to divide by two things that multiplied before. So you divide everything by 2. I should have paused the video so that someone watching this doesn't have to watch me talk. Okay, let's get to it. That's what that diamond would factor out. So on our top, our second equation, we have 3 and then 2x minus 5 and 2x minus 5. Divide by. On the bottom, you can take a GCF out. The GCF you can take from the bottom would be a 2. So this thing would become 2x squared minus 9. And I took a GCF of a 2 out of that bottom, and I rewrote it out on the bottom for you to see. What do I notice about that x squared minus 9? It's a difference of squares. So x squared is a perfect square, 9 is a perfect square. That means it can be factored to become x minus 3, x plus 3. So I difference of squares, that x squared minus 3. That's just my first step, factoring. And like realistically, that was 1, 2, 3, 4, 5 different factoring problems in one little problem. So that's just, again, an example of how important factoring is. The second step after a factor is state your NPVs. My NPVs are anywhere I'm doing division and anywhere that it could possibly be 0. So the first one is going to be x cannot equal negative 3. If I look over at the second fraction in the blue, I also learned it can't be positive. If I look at my second fraction's numerator, so that's up here, I have 2x minus 5 in the brackets. I want to figure out what would make that equal to 0. I could do a little bit of math on the side of my paper by going 2x minus 5 equals 0. Move the 5 over, divide by the 2. Right? So you could do a little bit of algebra to figure it out. There's also a trick. The trick is that the number without the x goes on the top. The number with the x goes on the bottom. And it's always going to be the opposite symbol. So those are my NPVs. Negative 3, positive 3, 5 divided by 2. If that confused you, that's 3.2, right? So you should definitely go review your NPVs and how to find them. The third step is where we learned what today's all about. We have a fraction divided by a fraction. The way we solve that is kiss and flip. So change that division into multiplication. So now you're going to have 2x minus 5 divided by x plus 3 in a set of brackets, multiplied by 2x minus 3, x plus 3, divided by 3, 2x minus 5, 2x minus 3. Instead of writing it 2x minus 5, I could write it 2x minus 5 squared. Right? Like there's two of them, and that's all what squared means. So just a warning that if you ever see that, that's all that means, is that you have the binomial twice. Saves you some writing. Now I multiply across the top, multiply across the bottom. You're going to notice all you're really doing is rearranging things. Because again, it's multiplication. So all the binomials, you don't multiply them together. And all you're multiplying is your coefficients. So the 2 times the 2 is going to give me 4. And then everything else is going to stay the same. 2x minus 5, x minus 3, x plus 3. On the bottom, the coefficient can't even multiply with anything. So it's a 3, x plus 3, 2x minus 5, 2x minus 4. What's my last step going to be now that I've multiplied them together? Even cross out any packages that are on the top and the bottom. I have 2x minus 5 on both. I have an x plus 3 on both. Now you write out everything that was left over. So what's left over is 4x minus 3 divided by 3 times 2x. That is my final answer. And my Npvs I've written at the top, because I just always write them there for safety. So I never lose them in the madness that is the factoring 5 different things, and then multiplying and dividing and canceling, and all that madness. Any questions about those two? If you can do those, you can do any multiplication or division question you get thrown at you. Alright, there's 2 practice problems here. I'll put the answers on the board again, so you can try to work your way through them. Once you're done working your way through them, you can work in your practice booklet. You do have a quiz tomorrow. It includes what we did today. Okay, so it's going to be pretty much evenly distributed. You're going to have a little bit of factoring to start the quiz, a little bit of basic non-permissible values, and then some simplifying to finish it off. Okay. Yeah, just give me a second. You good? Same thing. Okay, awesome.